Alright, so let's do the part 9, and then this is going to be the last one for the lecture 4. The last stuff that I'm going to talk about is actually the standard enthalpy of formations. So that's the one that we are going to talk about. And then the symbol that we use is actually the delta H with the subscript F stands for the formations. And then the standard is actually in that little tiny circle, right? So that standard condition is at 1 atm, 25 degrees Celsius. So what is standard enthalpy of formations? So any molecule, right? So you start out, what's the heat or the heat or the energies, I guess, that required to actually make that particular molecule, one mole of that particular molecule, from the all elements of the standard state. So that energy is actually the standard enthalpy of formations. How much energy do I need to actually start from, literally from scratch, each most stable elements, to actually mix it up and then make this molecule, one more of that molecule. That's the standard enthalpy of formations. And generally speaking, that almost all the textbooks actually have this reference table. For example, like one of these guys, right? Standard enthalpy of formations. So if you are interested in making this ethanol, yeah, this is ethanol, from the pure carbon, that's graphite, and then pure hydrogen, that's a gas phase, pure hydrogen, and then pure oxygen. So mix all of those elements together, and then how much energy do I need to actually make this one mole of the ethanol, liquid ethanol? That energy is turned out to be the negative 277.6 kilojoule, which means that by forming it, making this ethanol, it actually releases the heat to the outward. By the way, that's the standard enthalpy of formations. And each molecules like this, they actually have all these associated standard enthalpy of formations for each one of these. So what's good is that going to do? Sometimes that we don't really have the delta H of the reactions, right? Because we have like millions of the chemical reactions, right? And there are only so much of the table that we can actually place it in the textbook, right? So many of the reactions are not listed as the delta H of the reactions. So in that case, if we all know that all the reactant standard enthalpy of formations and product molecules standard enthalpy of formations, then we can actually calculate the delta H of reactions. The useful rule, by the way, for the standard enthalpy of formations, the standard enthalpy of formation for an element, the pure element, in its most stable state, for example, like in the carbon, that could be the graphite or the diamond or the gas phase or the liquid. It's actually the graphite being 0. So let me just go back to the previous one. So it doesn't have the pure element, but the maybe one of these things probably have one. Yeah, like for example, like an aluminum, right? Just close to this. Pure aluminum, that's aluminum in the metal, right? The enthalpy of formation, the standard enthalpy of formation of the aluminum is actually 0. That means that it's the most stable form and it's pure element. And all of those guys is going to be 0. That's what I meant by the standard enthalpy of formation for an element in its most stable state must be 0. And then all you have to do is just use the table, learn to use the table. And be careful with the liquid or the gas or solid, because sometimes the liquid and gas, they have a different enthalpy of formations. And how do you actually get the delta H of the reaction? You add all delta HF value for the product. So product minus reactant, right? Because delta right here is always the final state minus initial state, right? So the final state being product. So add all the delta HF value for the product minus add all the delta H value for the reactant. So let me just clarify what I meant by that. But if you subtract this one from this guy, you get the delta H of the reactions. So for this one right here, you have this methanol and methane and oxygen reacting to make the carbon dioxide and then 2H2O, right? So you go to the table, for example, let me just go to the Jazz one, because Jazz one is a little bit easier to actually look it up. So H2O liquid and H2O gas. Notice that H2O liquid and H2O gas is different, right? One is negative 285, the other one is at negative 241. One is gas, one is liquid, right? So be careful with the state that they're in. So this one right here is liquid, right? So liquid means that I am going to actually get the table. Oh, what happened to the, yeah, right here. I'm gonna use this value right here, which is a 285.8, because that's liquid, right? So 285.8, negative 285.8. That's what I have here. And I have two of those, right? So multiply by 2. And then CO2, gas is the negative 393.5. Oops. That's this one. And I have only one of those, right? And the oxygen, the pure element, is 0. So even though that I have two of those, that's 2 multiplied by 0 is 0, right? And then CH4 gas, just for the completion, I'm gonna try to show you what CH4 somewhere right here, the 74.8, negative 74.8, right? So that's that. And then I have only one of those, right? So the key is add these things up, that's a product. Add these things, that's a reactant. Product minus reactant, you get this value right here. That's the delta H of reaction for this one. Simple enough. What I want you to do is pause the video and then try to solve this problem, and also try to solve this problem. I am not going to explain these guys, so you're supposed to look it up on if the information is necessary, Google it and then get the table. Only thing I did is this was the search keyword, standard enthalpy of formations PDF. That's pretty much what I look it up, and then you have plenty of any one of these is probably good enough to actually get you to these type of things. So you have all the informations, just need to solve it. Have fun.